Welcome back, everyone, and we are going to continue to get practice with those trig functions now that we know all their derivatives. So if I'm just doing these first ones really quick, I encourage you to pause the video, try it out yourself. As we press on though, I'm just going to recognize, okay, first I have a product rule, so I have to do 1, and then the derivative of the second piece, so this is my 1, this is my 2, so then I get derivative of tangent I know is secant squared of theta, and then derivative of theta is just minus 1. Okay, and then that's 1d2 plus 2 tangent theta minus theta d1 e to the theta. Okay, and what I could say here is that this is the same as tangent squared theta, and I could rewrite it. Okay, kind of the rule of thumb here is to make easy simplifications. Okay, but so don't overexert yourself like trying to factor. You could factor out a theta and make it look prettier, but your call. Okay, but my rule of thumb is make easy simplifications. Alright, when I'm doing y prime, again, I encourage you to pause the video, try this out for yourself. You have to do the quotient rule. So you'd have low, d high, 1 differentiates away, I can just get, oops, that should be positive, so just cosine x, and then, oops, low d high minus high, 1 plus sine x, d low, 1 minus sine x, all over low squared. Now, I'm going to leave it like that, probably simplifies nicely. It's going to be painful for me right now, so I'm going to leave it. Okay. Now we want to find each of these limits. This is kind of fun and aggravating all at the same time. Okay. What we remember is that the limit of as theta goes to 0 of sine of theta over theta is 1. And I'm going to try and pull that out as much as I can. So this first one, I have limit as x goes to 0. And now this x squared is actually x times x, right? So I can write this as sine 3x over x times sine 5x over x. Now what would be really nice is I notice that these thetas have to be the same. So that means I need a 3 and a 5 here. But if I introduce them in the denominator, I also need them in the numerator. So this would be times 3 times 5. Okay, and I can do that because it's effectively multiplying by 1. Okay, if I can do that, then I can say, okay, well, 3 times 5 is 15. That can come outside the limit. And then since I know these limits exist independently, right, I can use the limit law and separate them, or apply the limit to each piece. So I'm going to write this as times limit as x goes to 0 of, oops, sine 3x over 3x times limit as x goes to 0 of sine 5x over 5x. And then this just becomes 15 times 1, or 15. Alright, with the next example, again, I'm going to try to make use of that same limit identity as much as possible. The other one, just so you're aware, that was theta approaches 0, cosine of theta minus 1 over theta is equal to 0. I'm going to look for these two and try and use them. Okay. What I'm going to do though first is divide each piece by theta and see what I get. Okay, and as long as I do it to the numerator and denominator, I'm not changing the overall value. So this would be limit as theta approaches 0, sine theta over theta, all over 1, and then I'm going to write tangent actually as sine of theta over cosine of theta, and then I also need to incorporate that theta that's in the denominator there. Okay, now I want to use the quotient rule for the limit, but my question is, do each of these exist independently? The first one, yep, in the numerator, that one is going to work. That's just going to be 1. The second one down here is going to be 1. And then if I look and kind of separate this into two pieces, if I can think sine of theta over theta is 1. Cosine of theta as theta goes to 0 is going to be 1. So actually, I think I can write this as limit sine of theta over theta all over 1 plus limit as theta goes to 0 sine theta over theta times limit theta goes to 0 cosine theta. Okay, a little bit more complicated, but nevertheless, I did a few different limit laws all at once, and it was okay because all of them existed. Okay, so if I finish off the calculation here, numerator I get 1, denominator I get 1 plus 1 for this first part, and then also 1 for the second part. So my final answer is 1/2. Yay! Yay math. Isn't it fun? Alright, and then the last thing is that we have an example. I want to find a tangent line. Okay, so for this, we remember tangent line, I need to find the derivative and evaluate the derivative at the point of interest. So, and then that'll give me my tangent slope. So f prime of x is going to equal 2 minus secant squared of x. And then if I look at the point of interest is 0, I get 2 minus secant of 0, secant squared of 0, which is 1. So my slope is just 1. Then the last thing I need to do is evaluate my point. So I know that I would have 0 comma f of 0 as my point, 0, and then evaluating you get 0. So pretty boring tangent line, but we would have y minus 0. I'll write this tan line. Y minus 0 is equal to 1, x minus 0. And so just the line y is equal to x. Isn't that fun? Alright, so we got some practice with trig derivatives and then also that limit identity that we saw back in the definition of the derivative for sine. So continue to make sure to write or maybe make a list of those trig derivatives and get practice with those.